Yeah, okay. All right. So, okay, let's get started. So this is a webinar series on how to become a data-driven enterprise with AI. And this is our first episode. And let's get started. So first of all, what is CloudAEye? CloudAEye is a startup company that provides AI-driven observability for cloud-native applications. And please check out our website at cloudaeye.com. And my name is Badrul, and I'm the co-founder and CTO of CloudAEye. I have vast experience in AI and recommender systems, building large-scale models for the industry, and I have also have some experience with training and teaching AI models. So I was behind the AI Academy at LinkedIn that actually trained like 500 plus engineers to learn AI and deploy models in production. Okay. And please check out my LinkedIn profile or my Google Scholar site. Okay. So for agenda for today would be to first give you an overview of this webinar series, what to expect, what topics will be covered, and tools and contents provided. So we have created some resources for all of you to collaborate and to join, and also we have created things like GitHub, and also we have created Slack channel, community channel, so that we can all participate and talk about the problems and issues. Then we'll talk about what are the traits and qualities of data-driven enterprise, and if an enterprise wants to be data-driven, okay, how can they become data-driven, and what are the role of AI in making an organization data-driven. And then we'll talk about some basic AI concepts. Try to demystify the basics of AI, machine learning, deep learning, and data science, what are the differences between them. And then we'll talk about, if time permits, we'll show you some examples, code examples that I have prepared. If not, then I'll share with you guys. Okay, and then we will take some questions later on. Okay, so organizations of the webinar series. So we are planning a webinar like this every other week for approximately 15 to 20 episodes, and focus would be to cover the basic concepts of AI ML and how organizations can utilize them. And the format would be like interactive and QA, and also we will show you some code examples, so it'll be very practical and focused towards hands-on learning, and we'll provide resources as we said. Okay, and the topics for this would cover pretty much. So our focus would be so that someone can be hands-on with machine learning and data mining concepts that are used in industry today. So we'll cover a lot of materials, and then, as I said, everything would be practical and hands-on, and we will provide code examples and assignments. So this will range from introductory concepts to basic machine learning, supervised, unsupervised learning, and regression classification, and then we'll go into details in the subsequent sessions. We'll go over the details of classification algorithms such as logistic regression, trees, bagging, boostings, and for each of those we will provide some mathematical details and then a lot of code and practical examples. Then we'll talk about time series analysis, anomaly detection, forecasting, and things like that. And we'll later on focus a lot on the state-of-the-art models and techniques such as deep learning, feed-forward, and neural and recurrent networks, LSTMs, and then we'll talk about personalized recommendation, which is a very important concept for industry nowadays. And then we will also work through some practical applications such as image processing, and then NLP, natural language processing, recommender systems, and AIOps, which CloudAEye is actually specializing in. We'll also talk about emerging technologies such as transfer learning, self-supervised learning, as well as some of the concepts such as how to deal with privacy, fairness, explainability, and so on. Okay, so now let's take a look at, and then in today's webinar, we'll also show you some examples. So I've worked on some examples that I'll go over like towards the end of this. So basically, I have set up a simple model where I show examples of unsupervised and supervised learning. So we'll go into those towards the end of the lecture. So quickly now, you can take a look at this. So basically, we are talking about, so one of the theme is for this webinar is actually how can we make a data-driven enterprise through the use of AI, right? So nowadays, right, all the organizations, they are actually submerged in data, and especially the COVID pandemic has also created a lot of need for the companies to actually to have a lot of data driven. So it has forced the companies to become data driven, and in a data driven enterprise, right, the whole thought process starts from the culture of itself, right? So data can be leveraged to make better decisions, and it can be used to not only make the business decisions. Most important thing is that it allows you to gauge the customer sentiment, okay, and then streamline operations and so on. So a data-driven enterprise has certain traits, right? So the culture itself is fostered from the top of the organization, right? And the organization is very much like all the decisions are made by looking into data, not by gut feelings or other things, right? And these are done by choosing metrics very carefully, and employees and of the organization are encouraged to be data centric and are trained on latest technology, right? And and another important thing to become a data driven enterprise or doing machine learning AI is to provide a robust infrastructure for collecting, analyzing, and serving data, right? But it's hard, right? Cultural shift is very hard. It's way harder than you think. I have pointed to some articles where you can take a look later. Is that because the thing is that it has to come from the top, and it's not the technology that's the barrier to becoming a data-driven enterprise. It's the people, right? So one thing is that shortage of talent that have this data-centric mindset, right? And that hampers this a lot. And another thing is that the sheer volume of data that people generate and collect also poses a lot of challenge. And as a result, the data is not clean or not in a usable manner, right? And also there are some concerns about privacy. So to become a data-driven organization, so there should be, we need to all think differently, and then iterate and try, and what there is a term that is used widely, it's called fail fast, learn faster, okay, and focus on long term. So the bottom line here is that it is changing, it's transforming the organizations. So take some examples of data-driven versus traditional companies, right? So for example, like companies such as Airbnb has disrupted the hospitality market, right? And it has taken over using their muscles of data analysis and using data carefully and having a data-centric mindset, right? As opposed to traditional companies like Marriott and others. So there are tons of case studies such that shows this thing. So one thing about this becoming data-centric, yeah, for traditional companies, right? Data-centric means one thing is that it become more aware of data, look into more metrics, and then try to use data in decision making. But for some companies that use data as product, right? For example, Google's, Facebook's, and Amazon's of the world, right? So in those world, data is the main product, right? So in this case, data centric operations or using AI machine learning techniques actually is called the electricity of the company, or sort of the oxygen of the company, okay, for those enterprises. Okay. So now let's go into some basic concepts. Like we always hear the term AI versus machine learning versus deep learning versus data science, right? So what does it mean? Okay. So when we talk about AI, okay, AI actually stands for artificial intelligence, right? So in order to understand artificial intelligence, right, so we need to first understand what intelligence is. So basically here intelligence refers to human level intelligence. So any algorithm that tries to simulate that human intelligence, that falls under the artificial intelligence category. Here when you say human intelligence, it means cognition, that we can understand language, or we can understand an image as we look into that, right? So that kind of thing. So machine learning is, as you can see in this diagram, is a subfield of AI that aims to teach computers to learn from data, right? So given some data without any explicit programming, it allows you to learn from data. And deep learning is, again, a subfield of machine learning, okay, that uses particularly one particular technology called neural networks. And throughout the webinar series, we will take a deep dive into all of these algorithms and methodologies that run. And we hear another term called data science, okay, which refers to the scientific methods and algorithms to extract knowledge and insight from big data. So when you have big data, okay, so the knowledge, so it actually cuts across all this AI, machine learning, and deep learning. But here the focus is on finding insights from data and learning more about data and do a storytelling or represent data using visualization and other techniques. Okay, now let's take a look at machine learning algorithms. So when we say a machine learning algorithm, it actually means that that we are building some sort of a model or hypothesis given a training data. So from training data, we extract something called feature vectors, and then we apply some algorithms. So those are the algorithms that when you say machine learning or deep learning, so it refers to those algorithms. And ultimately, what we end up with is the model. And depending on the type of input that is given, or the training data that is given to the algorithm, machine learning can be of two types, supervised or unsupervised, where a supervised machine learning is where the input is given like an X and Y. So where X is the input feature and Y is a training label. So in a supervised machine learning algorithms, the training label is always given. For example, if you're learning whether we should provide a loan to someone, right? If you're a loan or a financial institute and trying to decide based on different features, like what is the income, what is the credit score, and what is the other features of a applicant, right? So you want to decide whether we should apply, we should give them a loan or not. In that case, if you want to train a model like that, then we'll give some data, and the label here would be whether loan was given to that person or not in past. And based on that, the model will learn a relationship between the input and the output, and then build what we call a model to predict, right? And this output can be either a continuous variable, like you're trying to predict income or life expectancy, or some number that is in a sort of a numerical range, continuous variable. Then we call this type of supervised learning algorithm regression, such as linear regression, tree-based regression, support-vector regression, and so on. But if the outcome variable or the label that is given to us is a binary label, for example, like loan approved or not, okay, something 0 or 1, something is a cat or dog, then this type of supervised learning algorithm is called classification. And there are lots of different classification. And in the next lectures, we will go into deep of these classifications one by one. So the examples of classification algorithms are logistic regression, decision trees, support vector machines, KNNs, and also the deep networks that we use, they fall into some sort of this classification algorithms. Although deep networks can do a lot of other things, but they also do classifications. On the other hand, unsupervised learning, as we said, when the data set is not labeled or tagged, so input is just a feature, and then there is no labels associated with it. So in this case, the algorithm that we can apply on this is do some sort of clustering. So like you cluster the data points based on some properties of them, like distance or other things that are given in these input features. And other things that we can do with this type of application is density estimation, dimensionality reduction, representation learning, autoencoders in the deep learning domain. So there are, of course, other types of learnings that we will also look into this series, and they are becoming very, very important. One important thing is semi-supervised learning, where, so one thing to remember is that if I have to make a comparison between supervised and unsupervised learning, that supervised learning is usually provides you with the more accurate results, but it's, on the other hand, it's very, very expensive, because getting label data is something that is very hard and very expensive, because it requires manual labor. Okay, and in that respect, there are algorithms that are provided that are called semi-supervised learning, where we provide some label data and lots of unlabeled data, and then use the algorithm in a clever way so that it can actually tell us about what data needs to be labeled next, and within by using a small labeling budget, we can achieve a much better algorithm. And there is this self-supervised learning. It's actually becoming very, very important nowadays. It uses common sense learning and becoming very important in some of the models that we'll see later on, such as like BART and word-to-vec or word vector type of algorithms, where they actually take an unsupervised data and then create a supervised learning out of that. And there is, of course, reinforcement learning, where the learning is done through trial and errors, if you can think of that way. Then it given a state and set of actions and a reward function, right? The algorithm decides what action to take. So a lot of game playing, and then like you probably have heard about the Atari games, and then the Go games that like the deep learning Go game has actually defeated the world champion in Go, which was sort of unthinkable. Okay, now let's and then let's move on to the coding example. And again, I apologize for going through these things a little fast, because of the earlier incidents of me having some problem with Zoom. So let me show you some of the code so this code I'll also share with you. And in this code, I have shown some very simple algorithms where we use a package called lazy predict. So basically here, if you even don't know anything about machine learning algorithms or what type of algorithms exist, right? And if you just have a data set, right? For example, I'm showing here the Boston housing market data set to illustrate the regression case. So I've given you the link to this data set also. So this Boston housing market data set actually has a lot of features about housing in the Boston area, and also the response variables. It's a regression problem. So it's think of this again. I said the supervised learning, right? So it has some features. So these will be the features, right? So and then it has the y variable is the median value of the house, right? And the task here is to actually predict whether what will be the, like, given this data set that some like 14 or 15 features here, the 13 features, and then the value finally that this is the home price, right? So what we are doing here is that we are building a model. We are separating the data into train and test part. So and then keeping the test part for evaluating the algorithms. And then using the train to build a model. So here I'm using since this is our first session, we are using an algorithm that is called a lazy regressor, meaning that we don't care what type of regressor it is. So it actually calls all the regression models from scikit-learn and then tries to fit a model. And you can see here that it actually makes the prediction, and then it shows you the models that are the best in this one, right? So you can see that it ran through all the different regressor, ADA boost regressor, bagging regressor, Bayesian, and all the things that you don't have to know at this point. It just goes through this and then fits a regression model. And then if we put the actual y-test into this at the end, right? So we'll see that this is where the actual is at the end, right? Has the actual value. So for the first use case, right, the home price was 23. So this is the test data set, meaning that the algorithm didn't see this value at all, right? So it used the training data set to build the model, and given the feature set, it predicted the value. So for the actual value of this home was 23.6, and all these regressors predicted some values. You can see that some of them were awfully close, right? This one gradient boosting regressor. And then some of this, what kernel ridge was really way off, right? Similarly, I have shown here a classification example. So this is actually based on the breast cancer data set. So this, I have also given a pointer to this data set. So this data set actually given some features of a radiology image. Actually, it predicts, and then the label given to it is that whether this tumor is benign or malignant, and the model that we are trying to learn here is whether we can predict, given some unseen features of these predictions, whether this is benign or malignant. And I've shown here some examples of all the classifiers possible. And if at this point, please remember one thing, is that we need not know the names of, need to know the names of these classifiers as of now. These are the ones that are used by this algorithm, lazy predictor. It goes over scikit-learn, there's a package, and runs all the algorithms, so that we can right now make some predictions, but later on we will go into details of some of these algorithms, and we'll see how they actually do this magic of predicting. And we will talk about evaluation and other related concepts for this. And I have provided you with some exploration ideas, so please download this notebook. So this notebook is hosted in something called Colab. This is a Google's facility where you can actually run any Python code, and they'll provide you a runtime environment where you can use GPUs and other things. So there I have given you two assignment type of thing where you can explore on your own. Like you can go to the Boston housing data set and do some exploratory data analysis. And there is a notebook that I have provided. You can just get some code from there and run. And then do some more analysis if you want to find which regressor and classifier performs the best. We know that, but we want to find, given a test case, right, which is the most difficult test case that all classifiers did poorly on it. So just to give you some pointers about exploring this data set. So I'm a little over time right now, so I'll stop here and take any questions you might have. Let's see if we have any questions or comments.
So I have one question. How do people get hold of this notebook that you just showed?
So yes, that's a very good question. So we will use our community Slack channel for now and the email list, because we are setting up the Git repository, and then we'll share it there. But right now, this notebook, it's public. So with the link, we'll provide you the link, and then with the link you can go there and then play with it. So it's just basically the code is all provided here. You have to just hit run. So there is some.
So maybe you can put it in the chat.
I can put it. Yeah, I can put it in the chat. Really, definitely. So, where's the chat? That's a good idea. Yeah. So, and please do let me know if you have any problem accessing this. Any other question from the audience? And again, my sincere apology for the mix-up at the beginning, but yeah, we'll be more organized going forward.
So what would be useful to hear is like, what would you like to see in this webinar? What could be useful for you guys? If you
Right.
can
So,
share
yeah.
some input, that would be useful.
Anyone?
Everybody is muted.
Any other questions from anyone? Or you can actually use the chat to let me know what type of, if you have any other questions, or please join our community Slack. I think the invitation was provided to all of you. So yeah, I can stay for a few minutes. If you have any questions, please go ahead. No questions.
Just for testing, could someone unmute and say something? I just want to make sure that people are able to talk.
Yeah, I think it is audible.
Okay.
Okay. All right. If there's no other questions, I'd like to thank everyone for joining the webinar, and hopefully, yeah, we'll have many more exciting sessions in future.
So I have one question. Is there a way where if you have some doubt, how we can reach out to you?
Yes, we have created a community Slack channel, and all of the participants and people who signed up for the webinar are added to the Slack. So I'll be watching the Slack channel for any questions, or yeah, that will be the best way to reach out to me.
Thank you.
Hi, I have another question.
Yes, please.
Would the recording of this webinar be posted?
Yes, that's the plan. So we are recording this webinar, and then it will be posted on our YouTube channel. Okay.
Okay, thank you.
Yeah, and another thing is that please, we are as a company at CloudAEye, we are actually always looking for AI and machine learning talents as well as cloud talents. So please feel free to contact us if you're interested in pursuing careers here. And also we have developed our MVP, and then we'd like to partner with companies to learn more about their pain points and see if there are ways we can help you, okay, with your DevOps headaches and pain points. Okay.
So hello.
Yeah.
Okay. It is just a simple question that should we do any pre-workout before the next lecture? So you are expecting to read something or to have certain hands-on before the next lecture?
Yes. I will provide you with the reading materials and slides ahead of time going forward. So this was the first time, so we were doing more of overviews and things like that. But for the next lecture, I'll share the slides and things that if you read early on, then it'll be easier for you to understand. Because starting from next lectures, we'll go a little bit deeper into the concept. So today it was like very, like you can think of it like 10,000 feet overview, right? So
Okay, okay. And I have one more question actually. After the completion of this all program, where will we stand after we'll find ourselves in the AI field?
Okay, that's a very good question, actually. So, so this webinar actually is focused on the state-of-the-art AI techniques, and so what we are, as you can see in the topic list that I shared, right? So we are covering quite a lot of topics, but it's not a complete coverage of AI ML, right? So what we'll be doing is that we'll be showing you the most practical ones that are used in industry and go into depth of all of this. So once you go through these sessions, and then we'll work on a lot of state-of-the-art applications as well, right? So for example, we are planning on doing like state-of-the-art classification using images, and then we'll be building a recommender systems. It will be working on using BART for NLP, and also using time series and forecasting models. So at the end of this, you will be more prepared for an industry machine learning, deep learning type of jobs. If you have some basic understanding, right, we'll try to go over those and provide you with reading materials. And at the end of this, and if you go through and follow all these examples and assignments that we provide, you will find yourself more prepared for the current requirements of MLDL type of job in the industry. Does that answer your question, Jason?
Yes, yes, it did, sir. Thank you very much for your wonderful session.
Thank you. Any other questions from? Yeah. Okay. If not, thank you very much, everyone, for joining the webinar. Okay. Thanks.